When adding or subtracting fractions, we need to make sure that they have the same denominators before adding or subtracting the numerators. Here's an example. 5 over 8 plus 2 over 8 equals 7 over 8. When the denominators are both the same, in this case 8 and 8, we can simply add the numerator 5 and 2 together, and that equals to 7/8. For subtraction, 5 over 8 minus 2 over 8 equals 3 over 8. The same situation, with the same denominator, we simply take the 5 minus 2, and that equals 3. So we have 3 over 8. And next, we have something called the mixed number. Mixed number is the sum of a whole number and a fraction. So, for example, if we have 12 3/8, this is equivalent to 12 plus 3/8. They're called mixed number because it's a whole number and then a fraction combined. So if we want to add a mixed number together, an example such as 12 3/8 plus 2 5/16, what we would do is we want to make sure that the denominators are the same. In this case, we have 8 and 16, so they're not the same. But what we can do is we can make both the denominators 16, because 8 times 2 equals 16. We would take first the denominator, times that by 2, the numerator times that by 2. We want to make sure that when you times the denominator, the numerator always also times the same number. And then we plus 2, and we leave this the same because the bottom's already 16 in this case. And the answer that we would have would be 12 6/16 plus 2 and a 5/16. And the answer for that would just be 14 11/16. Okay, so that would be the answer for the addition. Okay, now we're going to try some same denominator examples. Here's an example. 5 over 8 minus 2 over 8. And the answer would be 3 over 8. In this example, all we have is simply 5 minus the 2 equals 3. Because the denominators are the same, so there's nothing that's needed to be done on the denominator end. Now let's try a different question, but we're gonna use different denominators. Okay, the example would be 5 over 9 plus 2 over 5. Okay, now here we see that the denominators are not the same. So what we need to do is make them the same. And the way to do that is we see 9 and a 5, when we times them together, they equals 45. So what we want to do with the first number is because it's 9, so we need to times it by 5. And when we times the bottom by 5, we have to times the numerator by 5 as well. The second number is 5 on the denominator end, and we need to times that by 9 to get to 45. And the top is 2, so we also need to times that by 9. And the answer would come out to 25 45 plus 18 over 45. And the answer for that is 43 over 45. So that would be the answer. Now let's try an example with 3 different fractions added together. 3 over 5 plus 1 over 8 plus 1 over 8. In this example, we see there's denominator 5, 8, and 8. By looking at this question, we can tell that we can make the denominator 40 for all 3 of the fractions. So what we'll do is we'll take the 5, times that by 8, and do the same to the top. The second one, 8, we need to times by 5, and the top we need to times by 5. And the last one will be the same. And after we actually times it, we get 24, 40, 5 over 40, plus 5 over 40. After adding, now that we see the denominators are the same, all we gotta do is just add the top numerators, and that will come out to 34 over 40. And if we simplify that, basically divide 2 on top and divide 2 on the bottom, and we would get 17 over 20. So that would be the answer for this question. Now let's try a different question of addition with mixed numbers. An example would be 7 3/8 plus 6 over 1/3. Okay, in here we see the denominators are not the same. And we can make the denominator the same by taking 8 times 3, which is 24. So what we want to do is 8 times 3, and the top also needs to times by 3 as well. And then we bring the 6 over, and then we want to times the 3 by 8 and times the top by 8 as well. And that would equal out to 7 9 over 24 plus 6 8 over 24. And the answer for that would be 13 17 24. Now let's try a subtraction of mixed numbers. 10 1 over 4 minus 4 3 7. In this example, the denominators are 4 and 7. So we can tell that if we times 4 by 7, that will equals 28. So we can make the denominator the same by timesing the 4 by 7 and 7 times by 4. So in here, we have 10, 4 times by 7, and the numerator also needs to times by 7, minus 4, 3, 7. So the denominator needs to times that by 4, and the numerator needs to times by 4. Okay, and the answer would be 10 7 over 28 minus 4 12 over 28. Here we can see that the 7 over 28 is less than 12 over 28. So what we need to do here is to borrow 1 from the 10 here. And so this will become 9, and this will be 28 on the denominator and 35 on the numerator, minus 4 12 over 28. And the final answer would be 5 23 over 28. Now we want to talk a little bit about how we went from 10 7/28 to 9 and 35/28. For every 1 that we borrow from the 10, it's 28/28. So originally it was 10, 7/28. If we were to take away 1 from the 10, that would equal 9. And the 28 plus the 7 and the 28 that was originally here, then that would become 35/28. So that's why it became 35/28. Next, we want to talk about lines and segments. So a simple question of a line will look like this. It will have points on the line. For example, this is A, this is B, and this is C. When we want to describe the distance of A to B, we want to write it as AB with a line on top. And we want to talk about the distance between B and C. We want to write BC with a line on top. Okay, so if we were given a question where we state AB equals 7 1/8 units, and B to C equals 5 2/7 units. What is A to C? So the way we want to approach this is to first take the distance A to B and then add B to C. And since we know A to B is 7 over 1/8 and BC is 5 2/7, we can simply add it up like the mixed number question that we had previously. And in this example, we have two denominators, 8 and 7. So we know we can times them together for the denominator to be the same. So we're going to take 7 1/8 times by 7 and times the top by 7 plus 5 2/7 times by 8 and the numerator also by 8. And what we will get will be 7/56 plus 5/16/56. And the answer we will have is 12/23/56 units. Okay, so these are the examples of additions and subtraction of fractions and how to solve lines and segment questions. Here is an example. In this basic example, we're simply having 3/5 times by 4/6. So we're just taking the numerator times the numerator and the denominator times the denominator. 3 times 4 is 12. 5 times 6 is 30. Now we can see 12/30 to be both divisible by 2. So the answer that we would have, 30 divided by 2 is 15, and 12 divided by 2 is 6. So our final answer is 6/15. Here is another example. By multiplying the same method, 24 times 5, the answer is 120. Now if we times the denominator, 30 times 3, that would give us 90. We can further divide this both by 3. So we will end up with 40 over 30. Wait a minute. Now we can see the top and the bottom can both divide by 10. So let's do that again. So our final answer is 4 over 3. Looking at this example, we see that we simplify it quite a few times. So a good way would be to simplify before multiplying. So we're going to try an example where we are going to simplify before multiplying. In this example, 30 could be 5 times 6. And 45 could be 9 times 5. And 40 is equal to 8 times 5. And 10 will be 5 times 2. So here, we can see that we could simplify the 5 here, and then the 6 could be changed again to 3.2. And the 9 could be 3 times 3. So then we could simplify the 3 here. And same here, 8 can be changed to 4 times 2. So we can cancel out the 2. Now what we have remaining is 4, 2, 3, and since the denominator here are all crossed out, so we're left with 1. Then we just need to times them together. 2 times 4 equals 8. 3 times 1 equals 3. And we can't simplify anymore after this, so our answer is 8 over 3. Now let's take a look at the same question, but without simplifying. If we were simply to take 30 times 40, we would have 1200. And if we take 45 times 10, we will have 450. Now this looks like a big number to simplify after, so it would take multiple steps to simplify to the final answer. The numerator can divide by 10, denominator by 10, then we will have 120 over 45. Then we can see both numbers can be divisible by 5. Then we will have 24 over 9. Now 24 and 9 are both divisible by 3. And so our answer would result 8 over 3. Now this method works as well, but it's a longer process because then you have to divide the numbers multiple times rather than simplify before you multiply. Here is another example. By simplifying, we can simplify the numerator and the denominator, or we can simplify diagonally between the fractions. By looking at this question, we can see that 6 and 24 are both divisible by 6. And the 60 and 20, they're both divisible by 20. Now that we have the setup ready, we'll go ahead and simplify before we multiply. So the numerator here will be 6 times 1. And the denominator will be 20 times 1. The 60 will be 20 times 3. Denominator here will be 6 times 4. Then all we have to do is cross them out and cross the 20 out. And then what we have left, we would times them together. 1 times 3 is 3. 1 times 4 is 4. And that's our final answer. Now let's try another equation with bigger numbers. At any time during the video, feel free to pause the video if you need time to calculate yourself before the answer is determined. Now by looking at this question, what do we see that can be simplified? I see the 55 and 25, they're both divisible by 5. And I also see 46 and 24, both divisible by 2. So we'll write out like this: 5 times 11, 5 times 5, times 2 times 23, 2 times 12. Okay, so we can cross out the 5, cross out the 2, and now we're left with and by multiplying together, we'll have 253 over 60. 253 over 60. Now this can no longer be simplified further, so this would be our final answer. Now what if you times the fraction by a whole number? The first thing we need to do is convert the whole number to a fraction. So in this case, 9 would be equivalent to 9 over 1. So we'll write 10 over 3 times by 9 over 1. And here we can see 9 and 3 can both be simplified by 3. So we'll write it. So we can write it like this. Okay. And we can simplify the 3. And that's it. Then we are left with 10, 3, and 1 on the bottom. So the answer would be 30 over 1. And then that equals to 30. Now let's try one where we're multiplying 3 different fractions. Now, since there are 3 different fractions, it would be more difficult to determine what number to divide each of them by. Since there are 3 different fractions, we can simply just simplify the best that we can and then just further simplify as we go. So for 14, we know we can times that 2 times 7. And 36 would be 6 times 6. 24 would be 6 times 4. 50 would be 5 times 10. 21 would be 7 times 3. 33 would be 3 times 11. Now we can just kind of go through the numbers and see which one we can cross out. So the ones that I see is 6 and 6 here. Then 3 and 3. Now we can also further divide the number. Example, the 6 here could be 3 times 2. And the 4 here could be 2 times 2. And the 10 here could be 5 times 2. Then we could cross the 2 out. Cross the 2 here. And what we are left with is 7, 2, 7, 3, 5, 5, 11. And by multiplying them together, I will have 98 over 550. Now 98 and 550 are both divisible by 2. So our final answer will be 49, 275. So these are the examples of how to multiply fractions. I'll also have a video on how to divide fractions on the next video, so please stay tuned. Thank you for watching. Here is an example. When we are dividing fractions, we want to change the division to multiplication, and we want to reverse the fractions, the denominator to the numerator and the numerator to the denominator. So it will look something like this. Notice how we change from division to multiplication here, and we reversed the denominator and the numerator. Then the next step would just be multiplying them together. So we would take 5 times 7 and 2 times 3. So our final answer would be 35 over 6. Now at any time during the video, feel free to pause the video if you need time to calculate and get your own answer before we find out the answer. Here is another example. So we would do the same thing where we change division to multiplication, and then we flip the denominator and the numerator. So we would rewrite like this. Then we would just times them together, and that's our answer. Let's try another question with bigger numbers. Okay, so we know to leave this the same, change division to multiplication, flip the denominator and the numerator. Now let's look at this and see if we can simplify before we multiply. 24 and 2 we know can definitely divide by 2. The 37 and 11 There's nothing that you could simplify there. So we'll rewrite like this. 2 times 12 over 11 times 37, 2 times 11. So we can cross out the 2. Then we'll end up with 12 over 11 times by 37 over 11. And our final answer would be 444 over 121. Now, what if you were given a different format of division, a question that looks something like this? What we want to do here is rewrite the question. So this is equivalent to 46 over 81 divide by 28 over 15. After we've done this, then we know what to do next. So the same way as we've done before, 46, 81 times 15 over 28. Now we can try to simplify this before we multiply. We could see 46 and 28 both divisible by 2. The 15 and 81 are both divisible by 3. 46, we can get 2 times 23. 81, we know it's 9 times 9. Times 15, we know it's 3 times 5. And 28, 2 times 14. And from here, we can cross out the 2. And if we look at the number 3 here, we can see that it could cross out with a 9. So we'll change one of the 9 to 3 times 3. Then we can cross this 3 out with this one. Okay, now that we don't have anything else, let's see what we have left. So after we multiply them together, we'll have 115 over 378. Since we can no longer further simplify this, this would be our final answer. Now, what if we are dividing a fraction to a whole number? In this example, we need to first convert the 4 to 4 over 1. Then the next step should be easy. And from here, we can see 4 and 4. This can definitely divide by 4. So we can rewrite it. And cross out the 4. And we are left with 4 times 1 is 4. 9 times 1 is 9. And that's our final answer. Now, what if we are dividing a whole number by a fraction? Here is an example. Like the previous one, we have a whole number that needed first to be converted to a fraction. So we rewrite it like this. And then we want to change it to the multiplication format. We can see that 12 and 14 are both divisible by 2. So we can rewrite it like this. Now we can cross out the 2. And we are left with these. Then we just need to times them together. 6 times 9 is 54 over 7. And since we can no longer further simplify this, that would be our answer. So these are examples of how you would divide fractions. We also have videos on how to add, subtract, and multiply fractions. And you can check them in the description part of the video. Thank you for watching.